Look at 14C. So what have we got? We've got to find the sample size. So we need to find the value of n given certain conditions. So the probability of winning a prize in a game of chance is 0.48. So this is a binomial distribution. N, so we usually write NP. So in this case, the binomial is N. I'm not sure how many games. P, probability of success, 0.48. What is the least number of games that must be played to ensure the probability of winning at least once? The probability of one or more is greater than or equal to 0.95. So essentially we'll consider it as a equals 0.95, and then we just need that or more games. So the probability that X is greater than 1, that means that it's 1, 2, 3, 4. In fact, it's everything except for equals 0. So 1 minus the probability that X equals 0 is 0.95. So the probability that X equals 0, what I'm going to do is whip this over here and whip this back here. So you'll end up with the probability that X is 0 is 1 minus 0.95, so that's 0.05. Right, so we know from our formula, that binomial formula, nx p to the x, 1 minus p to the n minus x. All right, so what have we got? We've got n choose x, n choose 0, p to the 0, 1 minus p, 0.52, to the n take 0. And we know that that has to be 0.05. Now, at this point, if I don't have a calculator, it's pretty tricky. There might be questions that pop up with parts of it. So, for example, I know that n choose 0 is 1. I know that 0.48 to the 0 is 1. So, essentially what I'm solving is 0.52 to the n equals 0.05. And if you use your calculator to solve that for n, you get n equals 4.58. So to equal 0.95, you have to play 4.58 games, or to exceed 0.95, you would have to play 5 games, because you have to play more than 4.58. There's another way to do it, and that's on your calculator. And you do, I believe it's menu 55D, but watch the next little bit and just check that that's what we want. So I'm going to get my calculator out and I'm going to go, that's my menu, probability, distributions, and then the one I want to go down to is inverse binomial with that n. So the cumulative probability, that's the 0.05, the probability of success, 0.48, successes, we look at that 0 when we went 1 minus the probability of x equals 0, and we enter that in, okay, and the answer is 5 games. So most of the time you will actually do it with a calculator, and when you do it that way it's really quick, but I did want to show you the by hand method because who knows what's going to come your way. So that's A. Let's have a look at B, and in B I'm just going to do it on the calculator. What is the least number of games that must be played to ensure the probability of winning at least twice, so 2 or more, is more than 0.95? So we'll solve where it's equal and then we'll get more. So x is greater than or equal to 2. That's 1 minus everything except for 0 and 1. And that equals the 0.95. So you can see this time, like last time when we used the calculator, we used x equals 0. This time when we use the calculator, we'll put x equals 1. And again, it would be 0.05 because when we rearrange this whole thing, we'd get PR x equals 0 plus x equals 1 equals 0.05. because we're going to rearrange to get rid of the 1. All right, so the numbers that we're going to use are 1, 0.05, and the probability P. So let's do it. Menu 55D. So we'll get to this one. Cumulative probability this time is 1. The probability of success is still 0.48, and the successes is still 0.05. There we go. What did I do wrong? Let's have another go. I've done it the wrong way. I'm not going to re-record this though. let's just go here. What I might do is just copy down this previous one here. Still 0.05, still 0.48, but this is meant to be 1. And this time it's 8, so you have to play 8 games. Just be careful where you put those numbers, hey, because otherwise you're going to do the same as I did. So 8 games using your calculator. So up to you how you do it, but please have a go now at exercise 14C.